Have you ever wondered what's happening inside that box on your desk, or that sleek laptop you carry around? It seems like magic, doesn't it? You click a button, and suddenly you're watching a video from the other side of the world, writing a school report, playing a game in a fantastical universe. But it's not magic, it's science. A computer is an amazing machine designed to follow instructions, called programs, to do all sorts of incredible things. It takes in information, thinks about it really fast, and then shows you the result. Consider this: science is all around us, and the computer is one of the most powerful tools science has ever given us. Think of a computer like a super-organized city. It has a downtown area where all the big decisions are made, warehouses to store things, roads to move information around, ways for people, that's you, to interact with the city. Every single part has a specific job to do, and they all have to work together perfectly for the city to run smoothly. If one part slows down or stops working, the whole system can get gummed up. Understanding how this digital city works can help you become a better digital citizen, making you a smarter user and even helping you fix problems when they pop up. It's a journey into an electronic world that is fascinating and powerful. Every great team has its star players, and a computer is no different. Let's start with the input devices. These are the tools you use to talk to your computer and tell it what to do. The most common ones are your keyboard and mouse. Keyboard. When you type a letter on the keyboard, you are sending a specific signal, an instruction, into the computer. Mouse. When you move your mouse and click on an icon, you're giving it another command. Think of these as your voice and hands in the digital world. Microphones, webcams, and scanners are also input devices. Microphones, webcams, scanners. They all take information from the outside world and turn it into a language the computer can understand. Next up, we have the output devices. These are how the computer talks back to you. After it has processed your commands, it needs a way to show you the results. The most obvious output device is your monitor or screen, which displays everything from words and pictures to movies and games. Words, pictures, movies, games. Your speakers are another output device, bringing you sound, music, and voices. Sound, music, voices. A printer is also an output device. It takes the digital information from the screen and puts it onto physical paper that you can hold. These devices translate the computer's digital language back into sights and sounds that we humans can easily comprehend. Now, let's talk about storage. A computer needs a place to keep all of its files and information, even when it's turned off. This is the job of your storage drive, which might be a hard disk drive, or HDD, or a solid-state drive, SSD. HDD, SSD. Think of this as the computer's library or filing cabinet. At the very heart of the computer is the Central Processing Unit, or CPU. This is the computer's brain. It's a small, powerful chip that does almost all of the thinking and calculating. Every time you click, type, start a program, you are sending instructions to the CPU. Its main job is to fetch these instructions, figure out what they mean, and then execute them at an incredible speed. A CPU can perform billions of calculations every single second. It is the master decision-maker, the engine that drives everything else. Think of it as the head chef in a giant kitchen, reading the recipes, your commands, and telling everyone else what to do. The speed of a CPU is measured in gigahertz. A higher number means the CPU can think faster and handle more instructions per second. Imagine our chef in the kitchen. A 3 gigahertz chef could read and act on 3 billion recipe steps every second, while a 4 gigahertz chef could handle 4 billion. This speed is why your computer can handle complex tasks like editing videos, playing high-definition games without stuttering. Now, the CPU can't do its job alone. It needs a workspace, a sort of short-term memory for what it's working on right now. This is called random access memory, or RAM. Think of RAM as the CPU's countertop space. When you open a program like a web browser, a word processor, the computer pulls the necessary information from its long-term storage, the filing cabinet, and places it onto the RAM, the countertop. This allows the CPU to access the data it needs instantly, without having to go back to the filing cabinet every time. So how do all these parts, the brain, the workspace, the library, the rest, work together? Let's walk through a simple example: opening a photo. Flowchart. mouse click, CPU, storage drive, RAM, CPU, monitor. First, you use an input device, your mouse, to double-click on the photo's icon. This action sends an electrical signal through the motherboard to the CPU. The CPU, our super-fast brain, receives this signal and understands it as a command. Open this specific photo file. It's the starting pistol for a race of information. Every click, every key press starts a similar chain reaction inside the machine. The CPU now knows what to do, but it needs the photo file itself. It sends a request via the motherboard's roadways to the storage drive, the library or filing cabinet. The storage drive locates the photo file among all the other saved data. It copies that file and sends it over to the RAM, the CPU's temporary workspace. Placing the photo in RAM makes it much faster for the CPU to work with. Now that the photo is in RAM, the CPU can get to work. It processes the file, interpreting the digital code for colors and pixels. The CPU performs millions or even billions of calculations to translate that data into a visual image. Finally, the CPU has the finished image ready. It sends the final visual information through the motherboard to your monitor. The monitor lights up tiny dots, called pixels, with the correct colors to recreate the image. And all of this, from your click to the photo appearing on screen, happens in a fraction of a second. Understanding the basic components of your computer isn't just for tech experts or computer scientists. It's for everyone. Think about it. When you know what each part does, you become a much smarter shopper. Instead of just looking at the price tag on a new laptop, you can look at the specifications. This knowledge empowers you to perform basic troubleshooting. This knowledge opens up a world of potential upgrades. Most importantly, learning how computers work demystifies technology. This curiosity is the foundation of science and innovation. By peeking inside the box and learning the language of components, you step toward being not just a user of technology, a creator, an innovator, and that is, without a doubt, super cool. Consider it understood.